In our next example, we're going to look at multiplying polynomial expressions. Here we're asked to multiply x plus 5 times x plus 6. Now these are two binomial expressions, as each set inside the parentheses has two terms, one term and a second one, and then one term and a second one. When we have a situation like this, we're going to use a process that is labeled FOIL. FOIL stands for the order in which we're going to multiply. The F stands for first. The O stands for outer. The I stands for inner. And the L stands for last. And we'll demonstrate that on this example. So rewriting, we have x plus 5 times x plus 6. The first terms would be the first term in each of our expressions. That is the x times the x. So if we look at these multiplied together, that will give us the first term in our product. We're now going to look at our outer terms. The outer terms would be the x that we see here and the 6 that we see here. Now, we will pick up the signs in front of these terms also. So this is a positive x multiplied times a positive 6. So we're going to have plus 6 times x. The I stands for the inner terms. That's going to be the terms that we see in the middle. And that would be positive 5 times x, which will give us a plus 5x. And then we see our L, which stands for last. The last terms would be the 5 and the 6. We'll multiply those together. Positive 5 times positive 6 will be plus 5 times 6. Now we're going to simplify. X times x is x squared. We end up with 6x plus 5x plus 5 times 6 is 30. And finally, to simplify, we'll combine our like terms, which is going to give us x squared plus 11x plus 30. Here's another example where we're going to use our FOIL method. We want to multiply 7x plus 5 times 4x minus 3. Again, let's recall FOIL when we're multiplying two binomial expressions: first, outer, inner, last. So we're going to start off with our first terms. We have 7x multiplied times 4x. Our outer terms would be the 7x multiplied times our last term, and we need to pick up the sign in front of it. So we can write this to start with as an addition of 7x times negative 3. Our inner terms, we have a positive 5 multiplied times the 4x, so that's going to be plus 5 times 4x. And then our last terms, we have positive 5 times negative 3. So we'll say it's plus 5 times negative 3. Let's simplify. 7 times 4 is 28. And then x times x is x squared. We have the addition of 7 times negative 3, which is negative 21, times x. Plus 5 times 4 is 20 times x. And then we have plus 5 times negative 3, which will be negative 15. Continuing on, we have 28x squared. In the middle, we notice that we have a negative 21x and a 20x. That can be combined to give us negative 1x, and we don't have to write the 1 down. And then when we are adding a negative 15, we can think of that as subtracting 15. Now, as you become more proficient with this method, instead of putting the plus sign with the negative here, you can go ahead and evaluate and see that this is going to be a subtraction of 21x. And likewise, at the end, we could write down 5 times negative 3 is negative 15 right at the outset. In our next example, we're going to look at factoring a trinomial. Factor x squared plus 5x plus 6. Here's the process we're going to use. We look at the fact that our first term is x squared. Because of that, we're going to break this up into two factors, where x is going to be the first term of each factor. Remember that in the FOIL method, we would multiply the first terms together to give us the first term in the product. So x squared can be factored as x times x. The next thing we're going to do is to list all pairs of the factors of the constant. The constant term in this expression is 6. And notice it's a positive 6. So if we're listing all pairs, we could notice that we can have 1 multiplied times 6. We could have negative 1 multiplied times negative 6. We could have 2 multiplied times 3. Or we could have negative 2 multiplied times negative 3. Now, step 3 is to try various combinations of these factors. As you are starting out, you'll want to start by writing all of this down in order to see how to associate this in terms of FOIL method. As you become more proficient, you'll be able to jump to the answer quickly. So we'll start by doing the following. We go back to our x and our x, and we're going to take our numbers pairwise and put them into this situation. So that would be plus 1 and plus 6. That would be one combination. Let's just go on to the next. We have our x and our x. And we would take our other pair of factors. That would be negative 1 and negative 6. We could take the x and the x. Take the positive 2 and the positive 3. Or we could have our x and our x with the negative 2 and the negative 3. Now, we know that in all 4 of these combinations, we're going to end up with our first term of x squared and our last term of positive 6. So what's really going to make the difference is what happens with our inner and our outer terms. We need to come up with a positive 5x in the middle in order for this to be the correct factorization. So we're going to run through these individually to see what occurs. Let's do our outer and our inner terms in each. And what I'm going to do is just write that down in the blank next to each one. We're going to have our outer term of 6x and our inner term of 1x, and that would give us a middle term of 7x. If we have our outer term of negative 6x and our inner term of negative 1x, that would give us a middle term of negative 7x. If we have our outer term of 3x and our inner term of 2x, that would give us our middle term of 5x. If we have our outer term of negative 3x and our inner term of negative 2x, that would give us a middle term of negative 5x. Which one do we want? We want the one that ends up giving us the positive 5x in the middle. So our factorization should be x plus 2 times x plus 3. We can verify this by multiplying back out, just to make sure. So we're going to use FOIL method, which would give us x times x, which would be x squared. Our outer term would be x times 3, which would be plus 3x. Our inner term would be 2 times x, which would be plus 2x. And our last term would be 2 times 3, which would be plus 6. And we can see that this is going to be x squared plus 5x plus 6. Now, the answer to your question, which is to factor this, would be the factorization x plus 2 times x plus 3. Now let's look at another example where we're factoring a trinomial. Factor x squared plus 3x minus 10. Once again, we notice that the trinomial that we're given has a leading coefficient of 1. That allows us in step 1 to enter x as the first term of each factor. Next, we're going to list all pairs of factors of the constant. The constant here is negative 10. So that means that one of the factors has to be positive and the other negative. We can list positive 10 times negative 1. We can list negative 10 times positive 1. We can list positive 2 times negative 5. Or we can have negative 2 times positive 5. Now let's try various combinations of these factors. We're going to, in each case, have our original setup. We'll take our first pair, which is positive 10 and negative 1, and write it down as plus 10 minus 1. In our second grouping, x and x, we have negative 10 and positive 1. That will give us minus 10 and plus 1. X and x, positive 2, which would be plus 2, negative 5 gives us minus 5. And finally, We have a negative 2 and a positive 5. We put in minus 2 plus 5. Now, because of the way we've set this up, we know that our first terms will multiply together to give us x squared, and we know that all of our pairings of our last terms will multiply together to give us the negative 10. So what we're really interested in is whether we come up with the 3x in the middle from one of these pairings. So we're going to be looking at our outer and inner terms in each case, and I'll just write that down to the right. The outer term here is negative 1x. The inner term here is 10x. 10x minus 1x would be 9x. The outer term here is positive 1x. The inner term here is negative 10x. Negative 10x plus 1x would be negative 9x. The outer term is negative 5x. The inner term is positive 2x. Combined gives us negative 3x. The outer term is positive 5x. The inner term is negative 2x. Combined gives us positive 3x. The inner term that we need is a positive 3x, which leads us to believe that the factorization that will work is the last one that we have listed. We'll verify that by using our FOIL method once more. We'll multiply first times first, which would give us x squared. Our outer term would be x times 5, which would be plus 5x. The inner term would be negative 2 times x, which is minus 2x. And our last term would be negative 2 times 5, which will be negative 10. And let's combine our like terms. And we can see that it does check. So our factorization is correct. In our next example, we're going to look at a trinomial where the leading coefficient does not equal 1. We want to factor 5x squared minus 14x plus 5. This time we need to find two first terms whose product is 5x squared. There's the f in our FOIL method. Well, to end up with a product of 5x squared, we really only have one choice. This is going to be 5x multiplied times x. Next, we want to list all pairs of factors of the constant. Now, to end up with a positive 8, we're going to end up multiplying perhaps 8 times 1. We could end up multiplying negative 8 times negative 1. We could multiply 2 times 4, or perhaps we're multiplying negative 2 times negative 4. Now, notice that we're going to try to proceed in the same manner as we did with our leading coefficient of 1. However, it turns out we're going to have more combinations this time. We have 4 different combinations here, but because our first term is not the same in each of these binomials that we come up with here, we're going to have to actually end up with 2 times 4, which is 8 different possibilities. Let's try various combinations of these factors. So we're going to start off with the 5x times x, and our first situation was 8 times 1. Now, we can end up putting the plus 8 and the plus 1 in this manner, or for this same factorization, perhaps it's plus 1 and plus 8. And I'm going to separate these just to keep track of what we're doing. We have our 5x and our x. Our second grouping of factors was negative 8 times negative 1. Perhaps it's minus 8 and minus 1, or perhaps it's minus 1 and then minus 8. Let's go to our other 2 pairs of factors. We have our 5x and x. We had that perhaps it was 2 and 4, plus 2 plus 4. But in the other order, that would be plus 4 plus 2. And the last grouping, we had negative 2 and negative 4. That could be negative 2 and negative 4 in this order, or minus 4 and minus 2. Now, we know that our first terms are going to give us the 5x squared. We know that our last terms are going to give us the positive 8. If we look back at the problem that we started with, our middle term was negative 14x. That's what we're going to be trying to figure out which of these 8 possibilities is going to give us that middle term. So in each case, we're going to write down the value that we'd come up with for our middle term. This time I'm just going to write it to the left as we go. We're going to have 5x plus 8x, that would be 13x. We have 40x plus 1x, that would be 41x. We have negative 5x, negative 8x, that would be negative 13x. We have negative 40x and negative 1x, that would be negative 41x. Let's do the same thing for our other grouping. We have 5x times 4, which would be 20x, plus 2, that would be 22x. We have 10x plus 4x, that would be 14x. We have a negative 20x minus 2x, that would be negative 22x. We have a negative 10x minus 4x, that would be a negative 14x. Recall that the one that we're looking for is a middle term of negative 14x, which means that we're going to verify this answer. 5x minus 4 multiplied times x minus 2. Our first terms, 5x times x, gives us 5x squared. Our outer term, 5x times negative 2, gives us a minus 10x. The inner term, negative 4 times x, is negative 4x. And our last terms, negative 4 times negative 2, gives us positive 8. Combining then, we come up with 5x squared minus 14x plus 8, which verifies that our factorization is correct. Here's another problem dealing with factoring a trinomial. Factor 6y squared plus 19y minus 7. Step 1. Find 2 first terms whose product is 6y squared. Well, it turns out in this case we have more than one choice. We could have 6y multiplied times y, or it's possible to have 2y multiplied times 3y, since there's more than one factorization for the constant 6. Now, we're going to have to list all pairs of the factors of the constant in step 2. The constant is negative 7, so we could have 7 multiplied times negative 1, or we could have negative 7 multiplied times positive 1. Our next step is to try various combinations of these factors. So let's begin. We can have the 6y times the y. We need to end up with a plus 7 and a minus 1, or perhaps it's 6y times y with the minus 1 and the plus 7. So we've got to come up with all of the different combinations. We could have our 6y times y, and if we're using the combination of negative 7 and positive 1, that could be minus 7 plus 1. We could have 6y times y, where we change the order, plus 1 minus 7. Or perhaps it's the factorization 2y times 3y with the combination of 7 and negative 1, plus 7 minus 1. And in the other order, 2y, 3y, minus 1 plus 7. And then our last combination, we could have 2y and 3y with negative 7 and positive 1. And in the other order, 2y and 3y with positive 1 and minus 7. Now, because of our setup, we know that our first two terms in our binomials will end up giving us the 6y squared. We also know that our last two terms will end up giving us the negative 7. So what really is going to make the difference is what happens when we take our inner and our outer terms. In our first case, we're going to have negative 6y as our outer term, positive 7y as our inner term. So negative 6y plus 7y will be positive 1y. We have a positive 42y minus 1y, which would be 41y. We have a positive 6y minus 7y, which would be a negative y. We have a negative 42y plus 1y, which would be negative 41y. In our next grouping, we have negative 2y plus 21y, which would be 19y. We have 14y minus 3y, which would be 11y. We have positive 2y minus 21y, which would be negative 19y. And we have negative 14y plus 3y, which would be a negative 11y. Let's go back and remember that in this problem, we are trying to end up with a positive 19y as our middle term. That occurs in this combination. So we're going to verify by using FOIL method. We multiply 2y times 3y to give us 6y squared. Our outer term would give us 2y times negative 1, which would be minus 2y. Our inner term, 7 times 3y, which would give us plus 21y. Our last terms, 7 times negative 1 would give us negative 7. And now we can see that we can combine our middle terms, 6y squared, negative 2y plus 21y is plus 19y minus 7, and that verifies our factorization. Now let's look at solving an equation using factoring. We have an equation, x plus 6 multiplied times x minus 3 equals 0. In this situation, we have two factors multiplied together equal to 0. Now this is the situation where we would have a number multiplied times another number equal to 0. When we have this setup, that indicates that either a equals 0 or b equals 0 or both. That means that if we can end up with our equation factored, set equal to 0, then we have an easy way to solve. We'll use that now. We have the factor of x plus 6, and we have either x plus 6 equals 0, or we have the factor of x minus 3, and perhaps that equals 0. Let's solve each linear equation. We can subtract 6 from both sides of this equation to come up with x equals 0 minus 6 will be negative 6. We can add 3 to both sides of the second equation to come up with x equals 3. Now let's just make sure we understand what this is telling us. It says if we take negative 6 and substitute it back into the equation, we're going to have negative 6 plus 6, which would be 0. Now if we substitute negative 6 in our second expression, we're going to end up with negative 9. But we know that 0 multiplied times negative 9 would end up equaling 0. Likewise, if we take the value of 3 and substitute it into the equation, 3 plus 6 would give us 9. But when we multiply that times 3 minus 3, we end up with 9 times 0, which is also equal to 0. So both of these numbers will end up being viable solutions to this equation. Now let's look at how we can use factoring in order to solve a quadratic equation. Solve x squared minus 6x equals 16. We're going to begin in step 1 by moving all terms to one side and obtaining 0 on the other side. We can accomplish this by subtracting 16 from both sides of the equation in this equation. We're going to have x squared minus 6x minus 16 equals 0. Now we're going to concentrate in step 2 on factoring the expression that we see set equal to 0. This time we're going to do a lot of these steps mentally. We're going to start off by noticing that our leading coefficient is 1. That allows us to start off with x times x. Next, we notice that we need to have factors of 16. Now, we're going to have to get negative 16, so we could either use 16 times negative 1. We could have negative 16 times positive 1. We could have 2 times negative 8. We could have negative 2 times positive 8. We could have 4 times negative 4. Or it's possible that we have negative 4 times positive 4, which of course is the same, although I've listed it in different order. It's the same here because of the fact that we have an x and an x. So let's think about which one of these groupings will end up giving us the negative 6x in the middle. Many times the extreme values, which are the ones that are the furthest apart, would give us a large number in the middle. Let's go ahead and try something that's a little more intermediate. That is, let's look at the 2 and the negative 8. If we put the 2 and the 8 here, and we have the positive 2 minus 8, we have our outer term of negative 8x, our inner term of positive 2x, which gives us our negative 6x in the middle. So this first try actually ended up giving us a correct factorization. Many times when you're doing this on your own, you're going to kind of quickly sketch in different values, see if they work, perhaps erase if they don't. Kind of a trial and error. Now that we have our factorization, we want to end up coming up with solutions by setting each factor equal to 0. So we're going to have x plus 2 equals 0, or x minus 8 equals 0. That's going to give us x equals negative 2, or x equals positive 8. Let's check those solutions in the original equation. If we take negative 2 squared minus 6 times negative 2, we're trying to see whether or not we end up with a value of 16. We can square negative 2 to give us 4, and then we're going to multiply negative 6 times negative 2 to give us plus 12, and that does equal 16, so that checks. Let's try the value of 8. We would have 8 squared minus 6 times 8. That's going to be 64 minus 48, and that difference is 16, so that also checks. Now we're going to look at another equation that we're going to solve by factoring. Solve 2x squared plus 7x minus 4 equals 0. The equation is already set equal to 0, so we can launch right in to our factorization. We'll look at our first term, 2x squared, and that can be factored into 2x times x. Next, we're going to look at our constant term of negative 4. We could think of the factors as negative 4 multiplied times 1, 4 multiplied times negative 1, 2 multiplied times negative 2. Let's see which combination is going to work here. If we put the negative 4 in with this first term, notice that we would have a common factor. Let's just write that over the side. We would have 2x minus 4. But notice that there was no common factor in the original problem. That's going to help us in that we're not going to have to even try this one because a common factor here could not occur if there was no common factor here. So we know that our first situation won't work, at least not in that order. Perhaps it's going to be in the other order, that is the 1 and then the negative 4. Well, that would give us, let's just go ahead and write it in. We'd have minus 4 and we'd have plus 1. It looks promising, but as we look at our outer term, we have a negative 8x. Our inner term is a positive 1x, and that would be a negative 7x. What it does do for us, however, is it kind of gives us some insight. If the signs were different, it would work. Let's try that. What if we had the 2x minus 1 and the x plus 4? This did not work, but it kind of leads us to this. We have 8x minus 1x, which would give us the 7x in the middle. So as you're going through your different steps, you want to learn as you go. Sometimes you can find out things just by trying one that doesn't work, which will lead you to the correct solution. At this point, what we're going to do is take each factor and set it equal to 0. So we have 2x minus 1 equals 0, or x plus 4 equals 0. Let's solve the first equation. 2x equals 1, divide by 2, x equals 1/2. In the second equation, x equals negative 4. So we have two solutions to this equation. Let's look at solving another quadratic equation. Solve 8x squared plus 2x minus 1 equals 0. This time, as we begin the problem, we note that 8x squared has more than one possible factorization. We could either use 8x times x, or we could use 4x times 2x. To determine which one to try first, we notice that the middle term is relatively small compared to our numbers 8 and 1. That usually indicates that we're going to take not the extreme values, but the ones that are closer together. Now, there's no guarantee that's going to work, but it does at least give us an indication of how to begin our trial and error process. So I'm going to start with the 4x and the 2x. We then notice that our last term, the constant term, is a negative 1. Now, there's only one way to factor that. That is negative 1 times 1, but we're unsure about the order. We could put the negative 1 here and the plus 1 here, or it's possible that we could have 4x plus 1 and 2x minus 1. Now, we can try these things mentally to figure out which works, or we can write them down. Let's see which one is going to be correct. If the 4x and 2x work, we're going to have positive 4x minus 2x, and that would give us a positive 2x. In our second case, it would be a negative 4x and a positive 2x, and that would give us a negative 2x. So the first one that we have listed is the correct one. Now that we have it factored correctly, we're going to take each factor and set that equal to 0. Solving, we can add 1 to both sides to give us 4x equals 1. Divide by 4, x equals 1/4. In our second, we have 2x equals negative 1. Dividing by 2 gives us x equals negative 1/2. So our solutions are positive 1/4 and negative 1/2. Now let's look at a problem where we'll use the quadratic formula. Solve using the quadratic formula. 2x squared equals 6x minus 1. To solve this quadratic equation using the quadratic formula, we need to begin by setting the equation equal to 0. We'll accomplish this by subtracting 6x and adding 1 to both sides of the equation. That gives us 2x squared minus 6x plus 1 equals 0. We need to have the quadratic equation in the format ax squared plus bx plus c in order to use the formula. We'll identify our a value equal to the coefficient of x squared, which is 2. Our b value equals the coefficient of x, which is negative 6. And our c value equals the constant, which is 1. The formula, which you should have memorized, is x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now we'll substitute into the formula. X will equal the negative of negative 6 plus or minus the square root of negative 6 squared minus 4 times our a value of 2 and our c value of 1. We'll divide this by 2 times our a value of 2. Let's simplify further. The negative of negative 6 is 6, plus or minus the square root of negative 6 squared is 36, minus 4 times 2 times 1, which is 8, divide by 2 times 2, which is 4. Simplifying further, 6 plus or minus the square root of 36 minus 8 is 28, divided by 4. Now we're going to take this expression and simplify further by working with the radical. We're going to have, again, x equals 6 plus or minus the square root of 28 divided by 4. We notice that we can rewrite square root of 28 as the square root of 4 times 7. Then we can take the square root of 4, which is going to be 2, and we'll pull that out from underneath the radical symbol, and we'll be left here with the square root of 7. Next, we're going to factor out a 2 in our numerator. That's going to leave us with 3 plus or minus the square root of 7 inside parentheses divided by 4. And now we see that 2 is a common factor, which can be divided out. Divide by 2 and divide by 2. And our final answer will be x equals 3 plus or minus the square root of 7 divided by 2. Now let's look at an application. The formula P equals 1/100th a squared plus 5/100ths a plus 107 models a woman's normal systolic blood pressure P at age A. Use this formula to find the age to the nearest year of a woman whose normal systolic blood pressure is 115 milligrams mercury. To use this formula, we need to recognize the value of P stands for systolic blood pressure, and the A stands for age. We're trying to find the age, which means we're going to try to solve for A, given that we have P equals 115. So we substitute 115 into our formula. Now, to solve this quadratic equation, we're going to begin by setting this equal to 0. So we'll subtract 115 from both sides of the equation. 107 minus 115 gives us negative 8. Now, to solve this, we see that our numbers are not values that are integer values, so we're going to use the quadratic formula in order to come up with a solution. We can recognize in the formula that we would have our A value as the coefficient of our variable squared, that would be 100th. Our B value is going to be the coefficient of our variable to the first power, which would be 500ths. And our C value is going to equal the constant, which is negative 8. Now we're going to be solving for A. A is going to equal, let's recall, it would be negative of the B value. That's going to be the negative of 500ths. Plus or minus the square root of, we'll take that B value of 500ths and square it, minus 4 times our A value, which is 100th, times our C value, which is negative 8, and we'll divide the whole thing by 2 times our A value of 100th. Now, to evaluate this, we're going to take a calculator and substitute the value that's underneath the radical first. If you're using a scientific calculator. If you're using a graphing calculator, you could actually probably put the entire thing in at once. Of course, you could do the same thing with a scientific calculator as long as you're paying attention to your order of operations. In order to evaluate this, then, we come up with, at the end, and you should double check me on this, using your own calculator, you should come up with your age approximately equal to 26 years. Now, we're going to use the following graph in order to verify this solution. So we want to take this graph and recall that the problem had to do with, given that we had a blood pressure of 115, we wanted to try to determine the age. So let's find 115 on this chart. It's going to be right in between the 120 and the 110. And we're going to be moving over on here to see where it intersects with the line that's drawn. We find that point, and then we move downward onto our horizontal axis. And remember that our answer was 26, and we can see that the graph does verify that our value, our age, would be in between the 20 and the 30, and it looks very close to 26.